Hi there, in this video I'm going to show you how to work out the determinant and inverse of a 2 by 2 matrix. Okay, so here goes. So in this case, let me title this determinant of a 2 by 2 matrix. So let me underline this. And then we'll go through inverse of a 2 by 2 matrix next. Okay, so supposing if I have a 2 by 2 matrix A given by A11, A12, A21, A22, okay, then the determinant of the matrix A, and you would write this as, so it's denoted by det of A, okay, or A with two vertical lines either side. So you could either represent the determinant by using any one of these notation, okay. And in order to work out the determinant, let me show you the process. So to work out, so I usually use this notation. So to work out the determinant of A, so we're going to be using, and we're going to use this 2 by 2 matrix, general matrix, as a means of explaining the concept. So in order to work out the determinant, what you need to do is first you multiply the elements along the leading diagonal. Okay, so the leading diagonal as outlined in red, and then you subtract, and then you multiply the elements along the lateral diagonal or the opposing diagonal highlighted in green. So first multiply the elements along the leading diagonal. So A11 times A22 is A11, A22. Then you subtract. Then multiply the elements along the lateral diagonal, highlighted in green. A12 times A21, A12, A21. Okay? So that is the approach that you need to use when working out the determinants of a 2 by 2 matrix. Okay? So you don't use this approach for 3 by 3 matrices or 5 by 5 and so forth. This is an approach unique to 2 by 2 matrices. Okay, so remember, first multiply elements along the leading diagonal, then subtract, then multiply elements along the lateral diagonal. Okay, so we're going to see that very soon. Now let me talk to you about how we work out the inverse now. So the inverse of a 2 by 2 matrix. Let me underline this. Now to work out the inverse, okay, of any matrix, the formula is, so for any matrix, the inverse, and we write the inverse in this way, okay. So the inverse can be found by calculating 1 over the determinant of that matrix multiplied by what we call the adjoint matrix. Okay, so this matrix A star, we call that the adjoint matrix. So where A star is the adjoint matrix. Okay. So there's a specific way to work out the adjoint matrix for a 2 by 2, and there's a specific way to work out the adjoint matrix for 3 by 3. Okay, so the methods are different for matrices of different dimensions, but for the 2 by 2 case, let me show you how to work out A star. Okay, so for the 2 by 2 case, so let me underline this. Now, supposing our matrix A is of the form A11, A12, A21, A22. To work out the adjoint A star, this is what you need to do. Okay? First you need to swap the elements along the leading diagonal. Okay? So swap the elements along the leading diagonal. So A22 appears here, A11 appears here. So just swap the elements along the leading diagonal. And then multiply the elements along the lateral diagonal, highlighted in green, by -1. So if I multiply the elements along my lateral diagonal by -1, I'll get minus, whoops, wrong pen, so minus A12 minus A21. So remember the procedure. So multiply elements along lateral diagonal by -1, and second bullet point, swap elements along leading diagonal. So swap elements along the leading diagonal, and at the same time multiply the elements along the lateral diagonal by -1. That is the concept to working out the adjoint matrix for the 2x2 case. Okay, so let's take it further with an example. So let me continue on the reverse. So let's work out the inverse of a 2x2 matrix. So example number 1. So in this case, question is find the inverse of, and in part A, matrix A is given by 2, 5, -1 and 4. Okay, so let's go back. So to work out the inverse, first we need the determinant, and we know how to work out the determinant. Remember, for the determinant, we're going to multiply the elements along the leading diagonal, then subtract, then multiply the elements along the lateral diagonal. So let's first find the determinant, and then we'll work out the adjoint by using this approach here. So step number 1. Let's work out the determinant of that matrix A. So leading diagonal, if I multiply the elements, 2 times 4 minus, and then multiply the elements along the lateral. So 5 times -1, and if I simplify, 2 times 4 is 8. 5 times -1 is -5, with this minus plus 5. Okay, and 8 plus 5, 13. That is the determinant of this matrix. Okay, so that is step number 1. Let me follow that through with step number 2. Now step number 2, we also need the adjoint, and remember the steps involved for the adjoint of the 2x2. So swap the elements along the leading, multiplying the elements along the lateral by -1. So in our case, our adjoint A star. So if I swap these elements along the leading, I have 4 and 2. Multiplying the elements along the lateral by -1, I'll have -5 and +1. Okay, so that is step 2. Step 3, final step, use the formula to work out the inverse. So this is a general formula to working out the inverse. So using, so A inverse 1 over the determinant times the adjoint. So when I replace the results, it's 1 over, the determinant is 1 over 13, and the adjoint 4 minus 5, 1, 2. Okay, so that completes that example. So here are the steps involved in order to work out the inverse of a 2 by 2 matrix. Okay, let's repeat the approach. So let's try another one, part B. So if I have a matrix capital B, if it's defined by 0, 1, minus 3 and 2, so let's do the same. Let's try and work out the inverse. So in step 1, let's work out the determinant first. So determinant of B. So remember, firstly, multiply the elements along the leading diagonal. So 0 times 2. Then subtract. Then multiply the elements along the lateral diagonal, highlighted in green. 1 times minus 3. So if we simplify, 0 times 2 is 0. 1 times minus 3 is minus 3. With this minus is plus 3. So the determinant of B is plus 3. Okay. Next, we need the adjoint. So that's step number 2. So let's go to step 2. Let me continue here. So in step number 2, our matrix B, remember, is this matrix 0, 1, minus 3, 2. So let's swap the elements along the leading diagonal for the adjoint. So now B star is 2, 0 when I swap the elements along the leading. And if I multiply the elements along the lateral by minus 1, this is what we're going to have, minus 1 and plus 3. So that is the matrix for the adjoint of B. And finally, in step 3, let's use the general result for the inverse. So the inverse of B is 1 over the determinant of B times the adjoint of B. So when I replace the results, the determinant, so let's remind ourselves, was 3. So it's 1 over 3 multiplied by the adjoint being 2 minus 1, 3 and 0. Okay. So what you could also do is you could multiply each of these elements by the scalar 1 over 3. So if you wanted to, you can simplify this further. So if I multiply each of these elements by 1 over 3, we're going to have 2 over 3. So 2 times 1 over 3, 2 over 3. Minus 1 times 1 over 3 is minus 1 over 3. 1 over 3 times 3 is 1. 1 over 3 times 0, 0. Okay, so you could go one extra step and multiply each of these elements by the scalar outside. Okay. So this is the calculation for the inverse. Okay. And here are the steps involved in order to work out the inverse of a 2 by 2 matrix. Right, let me also explain some conditions for the inverse. Okay, so let me give you some conditions. Now, you can only work out the inverse. So here's the general result when working out the inverse of a matrix of any dimension. So to work out the inverse, a determinant must exist. So if the determinant is not 0, then you can work out the inverse. Okay, so however, if the determinant is 0, we call that a singular matrix. So note, let's take a red pen and underline. Okay, so if the determinant of a matrix A is not 0, then we can calculate. So then we can calculate an inverse. However, if the determinant is indeed 0, we cannot calculate the inverse, and we call that matrix a singular matrix. So if the determinant of A is equal to 0, then A is called a singular matrix. Okay, so let me underline this term, singular matrix. So it's only singular if the determinant is 0. Okay, so another bullet point, so another result, if you multiply A by its inverse, or if you multiply the inverse by the matrix A, you're going to get the identity. Okay, so if you multiply a matrix by its inverse, or the inverse by its matrix, you're going to get the identity matrix I. Okay, so here are the conditions relating to the inverse. And remember, you can only work out the inverse if the determinant of that matrix is not 0. Okay, and also have a note of that condition as well relating to the inverse. So that ends this video. I hope you found this video helpful.